Hi everyone. Today we'll talk about logarithmic differentiation. Logarithmic differentiation is a technique of finding derivatives. To use it, we need to know logarithmic identities, so let us first review those. If you would like to try the next exercise on your own, stop the video now and download these notes using the link in the video description. I believe that ln of a plus ln of b is equal to ln of a times b. ln of a minus ln of b is equal to ln of a divided by b. ln of a to the power of b is the same thing as b ln of a. Most people remember this rule by thinking you take the b and move it down in front of ln. Finally, ln of e to the power of x is x, and e to the power ln of x is also x. And that is because the function ln of x and the function e to the power of x are inverse functions. You can think about it in the following way. ln and e cancel each other and give you simply x. Similarly, e and ln cancel each other and give you x. To use logarithmic differentiation means to use these identities together with the technique of implicit differentiation. And if you don't know what implicit differentiation is, I will add a link in the video description to a video in which I talk about implicit differentiation in detail. To show you the need for logarithmic differentiation, I have one more exercise. We are given three functions and we must find their derivatives. If you want to try this exercise on your own, stop the video now. The first function, e to the power of x, is a famous function. Its derivative is simply the function itself. It is e to the power of x. The second function is a power function. This function, x to the power of e, is very similar to the function x to the power of 5. If I was going to take the derivative of x to the power of 5, I would use the power rule and I would get 5x to the fourth. I do the same thing here, because remember, e is simply just a number. So to take the derivative, I take that exponent down and I decrease the exponent by 1. Finally, in part C, I have a dilemma. Which rule should I use? Should I use the exponential rule? Should I use the power rule? Or maybe something completely different? Note that I don't think I can use the exponential rule because the base is not e, the base is x. What's more, it's not even a number. The base of this function is a variable. I also cannot use the power rule because the power rule can only be used if that number in the exponent is a number. Unfortunately, here we have a variable in the exponent, so power rule does not apply. This shows a need for a new technique. That technique is called logarithmic differentiation. Let me show you how logarithmic differentiation works in practice. The first step is to name your function by the letter y. Then, take natural logs on both sides. ln of y will equal ln of x to the power of x. Keep in mind that your goal is to find the derivative of x to the power of x, which is the same thing as finding the derivative of y. So your goal is to find dy dx. Now, I chose to take the natural log on both sides because now, by using the properties of natural logarithm, I can take this x in the exponent and move it in front of ln. When I do that, I will get ln of y equal to x ln of x. My goal is to find the derivative of y with respect to x, so I will now take the derivative on both sides with respect to x using implicit differentiation. On the left side, I use the chain rule. Y is a function of x and ln of y is the outside function. So I get the derivative of the inside, dy dx, times the derivative of ln with the inside function plugged in. On the right side, to take the derivative with respect to x, I will use the product rule because I have a multiplication of two functions here. The derivative of the first function is 1. I multiply it by the second function, and I add to it the first function multiplied by the derivative of the second function. Second function was ln of x, the derivative is 1 over x. I can simplify this expression on the right side. That will give me ln of x, because 1 times ln of x is just ln of x, and x times 1 over x is simply 1. So I get ln of x plus 1. Now, my goal was to solve for dy dx, so I multiply both sides by y. When I do that, this will go away and y will show up on the right side. And I will get dy dx will equal to y multiplied by ln of x plus 1. This answer is not satisfactory. My original function was in terms of x, so I would like my final answer to be also in terms of x. Unfortunately, I do have y here. Thankfully, I know that y is the same thing as x to the power of x. So instead of this y, I can write x to the power of x, and I get dy dx equal to x to the power of x ln of x plus 1. This means that the derivative of y with respect to x is this, and because y was x to the power of x, this means that the derivative of x to the power of x with respect to x is this. Let's see if we understand how to do this by doing one more problem. Find the derivative of the following function. If you would like to try this on your own first, stop the video now. I follow the same steps. First, I name my function by y. So y will equal sine of x to the power x squared. Then I take natural log on both sides. Then I use the properties of natural log to move the exponent down, and I get ln of y will equal x squared ln of sine of x. Then I take the derivative on both sides with respect to x, and I get, on the left, dy dx times 1 over y. On the right side, I apply the product rule, first function, second function. That gives me the derivative of the first function, 2x, times the second function, ln of sine of x. I add to it the first function times the derivative of the second function. And to take the derivative here, I'm using the chain rule. I have the inside function and the outside function. The derivative of the inside function, the derivative of sine, is cosine. The derivative of ln is 1 over whatever was inside of ln. I need to plug in the inside function to it. To solve for dy dx, I multiply both sides by y, and I get dy dx equals, and I will say instead of y, I will write down what y was. So I will say sine of x squared multiplied by this expression, and I will get 2x ln of sine of x plus x squared, and instead of writing cosine over sine, I can write cotangent of x, because cosine over sine is the same thing as cotangent of x. This is my final answer. Sometimes you can use logarithmic differentiation even if you don't need to. Take a look at the next problem. We could find the derivative of this function without logarithmic differentiation. You simply apply the quotient rule, and while doing the quotient rule, you will apply the product rule whenever you take the derivative of the numerator. But you can simplify the computations, or you can avoid using the quotient rule or the product rule by using logarithmic differentiation. I will do that here to show you how it can be done. First, I name my function by y, so I have y equal to x squared e to the power of x over sine of x. I follow the same steps. I take ln of y on both sides, and I get ln of y equal to ln of the right side, x squared e to the power of x sine of x. This time, I will use a different property of natural log. I know that ln of something divided by something is ln of the top minus ln of the bottom. Take a look at one of the first properties we discussed. ln of a divided by b is ln of a minus ln of b. I will apply that rule right now. So on the right side, that gives me, I have ln of y gives me ln of x squared e to the power of x minus ln of sine of x. There's one more thing I can do to simplify this expression. I have ln of a times b. That's the same thing as ln of a plus ln of b. So this becomes ln of y equal to ln of x squared plus ln of e to the power of x minus ln of sine of x. Things get even better because I know ln and e cancel each other and I am left with just x in the middle term. So I have ln of y equal to ln of x squared plus x minus ln of sine of x. Now I take the derivative on both sides with respect to x, and I get, on the left, dy dx times 1 over y by applying the chain rule. I apply the chain rule now to the first term, and I get the derivative of x squared is 2x, the derivative of ln is 1 over whatever was inside of ln. The derivative of x is simply 1, and then I have minus, the derivative of sine is cosine, the derivative of ln is 1 over whatever was inside of ln. To simplify this, I will multiply both sides by y, so I will get dy dx will equal y times, and let's see what I get here, 2x divided by x squared, x at the top cancels with one of the x at the bottom, and I get 2 divided by x. Then I have 1, I don't think I can simplify it anymore, and finally, cosine divided by sine is cotangent, so I have minus cotangent of x. Finally, I want to have my final answer in terms of x, so I will replace y with whatever y was. So I will write that dy dx equals x squared e to the power of x divided by sine of x multiplied by 2 over x plus 1 minus cotangent of x.